Hello, everybody. So this is for week 8 problem set. Going to be talking about numbers 15 and 16. Okay. So all of these are about something we call a z-score. Okay? So a z-score is really just how far above or below the mean something is when you're counting it in standard deviations. Okay. Think of that as like counting in feet versus meters or something like that, right? It's just kind of the units that we use. So the idea is that if you were to graph the data, you'd come up with something that's kind of roughly kind of bell-shaped. Okay? Now, right in the middle of this is the mean. Okay? And there is some score, for, whoever, X. Okay? That's their test score or whatever it is. Now, you can find the standard deviations, which is standard deviations just roughly, you can think of it about it as your average distance from the mean. Okay? And so let's say that this is one standard deviation. Okay? What we want to know is where does this score compare? If we were to count in things that were this long, okay, this would be 2 standard deviations. Is it 2.5 standard deviations above the mean, or is it below, something like that? It's actually really super easy to compute. Okay, so to find the z-score, or the number of standard deviations, the z-score is just equal to whatever the data point is minus the mean divided by the standard deviation. Okay, so let's just say that we're looking at ACT scores. Okay, and let's suppose for a second you scored a 29. Okay, and let's further suppose the average ACT score was a 25 with a standard deviation of 15. How many standard deviations, how many standard deviations above the mean would you be? And my computer decided to go a little crazy here. Okay. So how many standard deviations away are we? Well, our z-score is then you scored the 29. We have to subtract the 25, which is the mean, and divide that by the standard deviation. So that would be 0.267 approximately. So you're about 0.267 standard deviations above the mean. So you're really close to the mean. Now, the reasons we might want to do this is comparing scores or something from different people to see kind of where they fall, especially like if you think about college entrance exam, you got the SAT and the ACT, and say, okay, well, who scored better? Well, we could compare them, even though the different tests have different ways of scoring stuff. Yeah, let me add some blank pages in here for this. All right, so let's suppose for a second that student A takes the ACT, okay, and the score they got was a 33. Right? With a mean for the group of, let's just keep it at 25, and standard deviation of 15. Now I'm just making these numbers up. I don't know if that's really the mean and stuff like that. Now student B comes along, but takes the SAT, and they score a 1350 on it. The mean for all students taking it, let's say, is 1,250 with a standard deviation of 125. Now, which student actually did better on the standardized testing? Well, to figure that out, we can compare their z-scores. So for student A, we'll go, okay, well, the z-score for student A, which remember, that's what we just call the number of standard deviations, okay, is 33 minus 25 divided by 15. So that would be 0.53. Now, student B's z-score would be the 1350 minus 1250 divided by 125. And their z-score is 0.8. So since student B has a score that's higher than student A's, when we talk about the z-scores, it's further away from the mean in the positive direction. You know, if we looked at the graphs of these things, we'd say, okay, well, here's the mean, okay? This would be student A, and further away would be student B. So student B got the better score, did better on his exam than student A did on the ACT. Now, we can also kind of go backwards from this sort of stuff and go, oh, well, if I want to be 2.5 standard deviations above the mean, okay, let's stick with the ACT. Okay. Again, we have the mean 25, standard deviation 15, and let's say we want score that is 2.5 standard deviations above the mean. Okay. So that would mean that whatever score I need minus the mean divided by the standard deviation had better be equal to 2.5. Okay. So we just have to solve that linear equation then. We'll multiply both sides by the 15. So let's see, 2.5 times 15 would be 37.5. Okay. Then we'll add the 25 to both sides. So x is going to be 62.5. So in order to be 3 standard deviations above the mean, they'd have to score 62.5. Now, if you took the ACT, you know that's not possible. But let me remind you, I'm making up numbers. Okay? Because I think the top score is 36, right? So I'm just making stuff up to show you how to work the problems and stuff. Now, let's alter this question. And instead of above, what if we want it below the mean? Okay? So what scores 3 standard deviations below? Well, we would set it up the same way. We'd have x minus 25 all over 15. But since it's below the mean, that would be a negative 2.5. Okay? Because we want it 2.5 below. So that would mean x minus 25 would have to equal negative 37.5. Add 25 to both sides. That'd be a negative 12.5. Man, so this person is so stupid, they got a negative score on the test. Okay? But again, let me reiterate, I'm making stuff up. Okay? Anyway, so this is really all you need to know about standard deviation, z-scores. Remember, we're just using it as a common unit of measurement. Okay? It's like if you have somebody in feet and somebody measuring things in meters, in order to compare those, you probably want them in the same units, right? So the units that we're choosing to compare things to compare things with is just the standard deviation is all. Okay? So hopefully this helps a little bit, and have a wonderful day.